Hello friends, let's evaluate the following limits. Okay, so let's start right away. For the first problem, you observe that this is a polynomial expression 3x to the power of 7 minus x squared plus 5x. That's a polynomial expression. So if you want to evaluate the limit of a polynomial expression, all you have to do is to plug in the value x is approaching. So x, from here you can see that x is approaching -1. So just plug in -1 and simplify. So I have 3 -1 to the power of 7 minus -1 square plus 5 -1, and a -1 to the power of 7. 7 is an odd number, so this is just going to be 3 -1. -1 square is just going to be 1. Then I have -5. This is just going to be -3, -1, -5, and these are -9. That's the limit of that function. The limit is -9. Okay, so for the next problem B, this is a rational expression, and when you are evaluating the limit of a rational expression, one thing you want to avoid the denominator being 0. If the denominator is 0, then you look for another way to evaluate that limit. So if we plug in 9, which is the value x is approaching, right? So plug in 9 into that expression, let's see if the denominator is going to be 0. If the denominator is not 0, then we are fine. So let's plug in 9 into that expression. So we have square root of 9 plus square root of 9 divided by 9 plus 9. This is just going to be 3 plus 3 divided by 18. This is just 9 divided by 18. This is 1 over 2. And that's the limit. So the denominator is 2, is not 0. So we are fine. Okay, let's look at this problem. Let's look at C, right? We want to evaluate this limit, right? Let's plug in 9, because x is approaching 9. Let's plug in 9 and see what we get. So clearly, if you plug in 9, you have square root of 9 minus square root of 9 divided by 9 minus 9. This is going to be 3 minus 3 over 0. This is 0 over 0. So you see that the denominator is 0. So this, we call this indeterminate form. Indeterminate form, because the denominator is what? Is 0. If the numerator is 0, that's fine. But if the denominator is equal to 0, then we must look for another way to evaluate this limit. So what other way can we evaluate this limit? Now, if you look at the expression, you can see that possibly the place where is looking a little bit complicated is the numerator, right, which is the square root of x minus square root of 9. So we can do something to that, and we can rationalize the numerator. So let me write this expression again. So I have limit as x approaches 9, square root of x minus square root of 9 over x minus 9, right? So we can rationalize the numerator. We can rationalize this numerator, and when you talk about rationalizing numerator, you're simply talking about multiplying the numerator by the conjugate of the numerator, multiplying not just the numerator, but multiplying the numerator and the denominator by the conjugate the of the numerator. So let me just write what I'm talking about. So what's the conjugate here? The conjugate is just going to be square root of x plus square root of 9. So if you observe that this sign here is negative and this sign here is positive, so that's the conjugate, right? So this is just going to be divided by square root of x plus square root of 9. Okay, and so let's simplify this expression now. And actually, if you observe that, if this, I'm not really changing the problem. If this divide this, I just get 1. So it's kind of like I'm multiplying by 1, you know. So if this divide this, I'm going to get 1, but I'm not dividing. I'm just, I'm not dividing, right? I'm multiplying. I'm not dividing. So it's kind of like I'm multiplying by 1. That's it. So this is just going to be, if I simplify the numerator, right? So I have square root of x minus square root of 9 divided by x minus 9. So I'm just going to write it this way because I want to explain something. Plus square root of 9. Okay, so um, so what I want to do is that I'm going to multiply the numerator. I'm going to multiply the numerator, distribute rather. So this square root of x will multiply square root of x here, and this square root of x will also multiply the square root of 9, and this square root of 9 will multiply square root of x, and square root of 9 will also multiply square root of 9. Okay, so if we perform that operation, we are just going to get a limit as x approaches 9. So you have square root of x squared, then you have a plus square root of x square root of 9, then you have negative square root of 9 square root of x, and you have negative square root of 9 squared. Everything divided by x minus 9. So I'm going to leave the denominator just the way it is. Square root of x square root of 9. Okay, so if you observe that the middle terms here, they will cancel out. The middle terms, they will cancel out. And for the square root of x square, this square here can cancel this square root of x. And this square, for the square root of 9 square, this square here can cancel the square root of 9. So I'm going to be left with limit as x approaches 9 of x minus 9, right? For the numerator, I'm going to be left with that, divided by x minus 9 square root of x plus square root of 9. And if you observe that this x minus 9 can cancel this x minus 9, so I'm going to be left with a limit of 1 as x approaches 9 of 1 over square root of x plus square root of 9. And now let me plug in 9. I can safely plug in 9. So if I plug in 9, I'm going to have 1 over square root of 9 plus square root of 9. This is just going to be 1 over 3 plus 3 is 1 over 6. And that's going to be the limits. That's going to be the limits. So yeah, if you see the three problems, they are different, and I hope this helps you understand limits. Thank you.